Right. For the lesson today, we are actually going to look at experimental probability, also known as relative frequency. By the end of the lesson, you should understand the definition of a relative frequency, which is also known as the experimental probability. You should understand the difference between a relative frequency and theoretical probability, and be able to predict the outcome of an experiment given their relative frequency. Now, let's go back to this slide that I've shown you a few weeks ago. Remember, when we are very sure that something will happen, 100% sure that something will happen, the probability is 100%, or actually is 1. If something that can never happen, which is impossible, for example, rolling a 14 with 2 regular dice is actually 0. Now, if you look at flipping a coin, theoretically, we know that we can get head 50% of the time or tail 15% of the time. Therefore, we call this even chance, and the probability is 50%. Now, let's have a look at what is experimental probability. Theoretically, when we say probability of an event, or P bracket of an event, that's a notation, is the number of favorable outcomes over the total number of outcomes. In this case, tossing a coin could be head or tail only, nothing else. Rolling a die is 1, 2, 3, 4, 5, or 6. So the total number of outcomes for rolling a die is actually 6. And the probability of getting 2, which is 1 out of 6. Now, let's have a look at tossing a coin. Theoretically, 50% of the chance we can obtain a head, or we can obtain a tail when we toss a coin. However, when we are doing an experiment, if we toss a particular coin 1,000 times, we could probably obtain 550 heads and 450 tails. Why? Because you know that the coin may not be actually fully balanced on both sides. So you may get 550 heads and 450 tails. And therefore, we can say that the probability of obtaining a head when we toss this coin is 55%, or 11 over 20. And the probability of obtaining a tail is 45%, or 9 over 20. Why? Well, these are all what we call sampling. It's experiment. The coin, tossing the coin, we will get close to 50%, but not actually 50%. Alright? So for this particular coin, we can say that the probability of head is 55%. Probability of head is 55%, and probability of tail is 45%. So therefore, for the next toss of this particular coin, the chance of getting a head is 55%. So if we toss the coin for a further 100 times, we can predict that we can obtain 55% times 100, or 55 times head. And 45% times 100, 45 times of tail. So these are what we call the expected outcome. Right, a quick summary. So theoretical probability, we know that the probability of an event is the number of favorable outcome over the total number of outcomes. Now, today we are concentrating on this, experimental probability or relative frequency. It is calculated using the result of an experiment or survey. So experimental probability is a relative frequency calculated from a number of repeated trials. So experimental probability is number of the times the outcome occurs over the number of trials in the experiment. So for example, we toss the coin 1000 times, 550 times we got head, and 450 times we got tail. So the probability of obtaining head is 550 over 1000. And the expected number of occurrence is actually probability times the number of trials. Alright, we must always remember the probability of that event must be greater than or equal to 0 and less than or equals to 1. Let's have a look at some examples now. So let's have a quick read. Clara has a die. She does not know the values 1, 2, 3, 4, 5, and 6 are equally likely. She rolls the die 2000 times and obtains the following results. Now, theoretically, we know the probability of obtaining 1 is 1 over 6, 2 is 1 over 6, and so on and so forth. But now, if you look at this situation, when Clara rolled the die 2000 times, theoretically, she should get even number of frequency for all 6 numbers. However, you can see that the frequency for 1 is only 290, frequency of 2 is 370, frequency of obtaining a 3 is 330, frequency of obtaining a 4 is 280, frequency of obtaining a 5 is 340, and frequency of obtaining a 6 is 390. So, let's use this table to calculate the relative frequency to estimate the probability that the next row will be a 2, an even number, and a number greater than 4. So for part A, 2, probability of obtaining a 2 is actually just 370 over 2000. Recall that you don't actually have to simplify probability. An even number. Even number is 2, 4, and 6. So we know that Clara would get 370 times of 2, 280 times of 4, and 390 times of 6. So therefore, in total, she will get 940 times of 2, 4, or 6. So therefore, probability of even number is actually 940 over 2000. Or what you can do is, in this case, is probability of 2 plus probability of 4 plus probability of 6, which is 370 over 2000 plus 280 over 2000 plus 390 over 2000, which is 940 over 2000. Right? So either way, you can do it. So a number greater than 4, only 5 and 6. So therefore, probability only 5 and 6 is 340 plus 390 over 2000, which is 730 over 2000. Alright, let's have a look at the next example. Now, I would like you to spend some time reading this question. So, you can see that this is a survey of 2000 people. So they are determining the hair and eye color. The results are shown in the table below. So in this case, someone with fair hair color and blue eye is 25. Alright, there are 25 people with fair hair and blue eye, and so on and so forth. So let's have a look at the first one. The relative frequency of fair or brown hair. Fair or brown hair. So in this case, we don't have to worry about the eye color. We just need to know that the hair is fair or brown. So the total number of fair hair would be 56. Total number of brown hair is 32. So now we can say that the probability of obtaining a fair or brown hair is actually 56 plus 32 over 200, which is 88 over 200. Alright, remember, OR means union. So you can actually use the notation of probability of F union brown hair. Alright? But I'm happy if you use this notation. Next thing, green hair and black eyes. Sorry, green eyes and black hair. So you know that it must be green eyes and black hair happening at the same time, which is only this little bit here. So therefore, probability of green eyes intersect black hair would be 16 over 2000. So this is how you actually look for relative frequency. Determine relative frequency, I mean. Next, let's have a look at expected outcome. So let's have a look at this example here. Chris plays rugby and has a record of kicking a goal from a penalty kick 4 times out of every 7 attempts. So state the experimental probability for Chris to achieve a penalty goal. So we know that it's 4 out of 7. So probability of achieving a penalty goal will then be 4 over 7. And part B, calculate the expected number of goals from 28 penalty kicks that Chris takes. So the expected number of goals equals to 28 times 4 over 7, which is 4 times 4 is 16. So Chris should kick 16 goals out of 28 penalty kicks. Alright, one last example. A box contains an unknown number of colored balls and a ball is drawn from the box and then replaced. The procedure is repeated 100 times and the color of the ball drawn is recorded each time. So 25 red balls were recorded out of 100 times. So find the probability, experimental probability for selecting a red ball. So the experimental probability or relative frequency of a red ball will then be 25 over 100. Now, you should be able to find the expected number of red balls if the ball contains 500 balls in total. So the expected number of red balls equals to 500 times 25 over 100. So we can actually simplify that, which is 5. That will give me 125 red balls. Alright, this is the end of the lesson for the day. So, just quickly reflecting on your learning. You should actually understand the definition of a relative frequency, which is also known as the experimental probability. You should understand the difference between a relative frequency and theoretical probability, and you should be able to predict the outcome of an experiment given the relative frequency. Please complete the homework that I have assigned you. Thank you.